Okay, so let's take a look at another electromagnetics question. We are told, given the following flux function, as presented on the right, to A, find del flux del time, and then B, find the induced EMF. So this flux function, it's pretty much a sine function, right? So the flux function in this case is pretty much sine of x. Del flux del time is going to be its derivative. Often in HSC physics, you won't have use of derivatives, but the rate of change of this flux with respect to time is going to be cosine of x, right? So this function, del flux del time, this is going to be essentially cosine of x in this case. So this is going to be something like cosine of x. It's going to have the similar amplitude to the function over here. So let's add it to the graph. So cosine starts high, it'll go down, go down. Cosine, of course, is just sine shifted by a little bit. So we have a curve down, comes back up, goes back down, and does this, and so on. So this is going to be the approximate function for del flux, del time. So this is the first part done. Now the second part says find the electromotive force. Well, we know that electromotive force is minus n times del flux del time. If we assume that n is 1, so we're going to assume that n is 1, assume n equals 1, it's just a single loop, then we will get that the electromotive force is going to be equal to minus cosine of x. We just found del flux del time was cosine of x. We have minus 1 in front of that. So it's going to be the cosine of x, but it's going to be upside down. So let's add this to our graph as well. It's going to start down here, come up here. It's just going to be the opposite of the cosine in red. When I say opposite, I mean upside down version. Rotated or flipped along the t-axis. So we get this, goes down here, comes up here, comes up here, goes down here, goes off like this. And this is going to be an approximate function for the electromotive force. So this is part B. And of course the magnitudes of these will change depending on the specific situation. In this very simple situation, we were not told a particular flux. We were just to assume it was the sine function. Therefore, we were to assume that the del flux del time was the cosine function. We were to assume n was 1. This means that the EMF is minus of cosine of x, right? So this was full of greatly simplified assumptions. If this question gets harder, if it has more parts and they tell you that there's multiple loops, these functions will potentially change amplitude. That's going to be the main change that you would see.